Welcome back, class. Today we're going to talk about our last bit of algebra that we need to calculate these derivatives using the limit definition. Namely, we're going to make sure we know how to handle radicals. Okay. So to start with, we're going to write down our same points. So 9, comma, and then f of 9 would be 3. And then 9 plus h, comma, and then f of 9 plus h, that's just going to be the square root of 9 plus h. Okay, so nothing too messy so far. Okay, we're then going to write down the average rate of change between these things, which is going to be the square root of 9 plus h minus 3 divided by h. 9 plus h minus 9. Okay. Now, your first instinct upon seeing this might be to say, hey, great, we're done. It's already as simple as I can get it. But I want to remind you, we're not done simplifying until we've gotten rid of the h. We've not gotten rid of the h yet. And no, you can't just cancel the h here and the h there. That will not work. Rather, what do I have to do? Well, I have to call back to the trick we talked about in section 2.2, so you can go review that video if you want, where we want to get rid of a square root, and the way we can sort of get rid of a square root is by multiplying by the conjugate. Okay, so namely, I multiply by 9 plus h plus 3 divided by this same thing. And so the numerator here is going to become 9 plus h minus 9. Okay. Again, remember the secret here is that the cross terms, I get a plus 3 times the square root of 9 plus h and a minus 3 times the square root of 9 plus h, and those just cancel. So the only terms I really get are the square root of 9 plus h times the square root of 9 plus h, which is 9 plus h, and the 3 times 3, which is the 9. And I said this would get rid of the square root. It didn't really get rid of the square root. I still very much have a square root. The square root is just in a better place. And I say the square root is in a better place because now we have these h's hanging out here where I can go ahead and cancel that h and that h, which is going to give me 1 over the square root of 9 plus h plus 3. And that is my average rate of change made all pretty. And then what do? We go ahead and take the limit as h goes to 0. So f prime of 9 is the limit as h goes to 0 of 1 over the square root of 9 plus h plus 3, which will be 1 over the square root of 9 plus 3, which will be 1/6. Okay, so let's do another example here with a square root. So to start, let's write down the points. So 6, comma, and then I have to plug in 6 here, which will be 12 minus 3 under a square root. So that's 9 under a square root, so that's 3. And then 6 plus h, comma, and so then g of 6 plus h, that's going to be the square root of 2 times 6 plus h minus 3, which is going to be the square root of 12 plus 2h minus 3, which is going to be the square root of 9 plus 2h. So that is our y-coordinate here. We write down our average rate of change. And as before, we're going to have to multiply by the conjugate in order to make this work. Because again, remember, I can't make progress until I've dealt with this h. Okay, so again, the numerator works out beautifully. I get a 9 plus 2h minus 9. And now I've got this ugly square root thing in the denominator that's just going to stay there. So canceling out the 9s, we get here, at which point we realize, hey, we can cancel the h's, and so we end up here. And so for our last step, we go ahead and calculate that this derivative g prime of 6 is the limit as h goes to 0 of this whole thing. Which is 2 divided by the square root of 9 plus 3, which is 2/6, which I'd write as a third. Okay, and one last example for the road. We now have a square root in the denominator instead of the numerator, but similar idea. I want to take as my point here 4, comma, and then this is going to be 4 divided by 4, which is going to be 1. And then we'll go ahead and figure out k of 4 plus h is going to be 4 plus h divided by the square root of 4 plus h plus 2. Well, I guess that's as nice as it's going to be. So make this 4 plus h divided by the square root of 4 plus h plus 2. And what's our average rate of change? Our average rate of change is, and because this is a fraction again, I'm going to go ahead and put the h that's going to end up in the denominator as a 1 over h out front to start with. But you don't have to if you don't want to. So it would be, normally it would be that minus that divided by 4 plus h minus 4, but I'm going to write, instead of divided by h, which is 4 plus h minus 4, I'm just going to write 1 over h times. Okay, so let's try and simplify this. So I need to put this over a common denominator. Which is going to be root 4 plus h plus 2. And so my numerator here is going to be 4 plus h minus the square root of 4 plus h plus 2. And let me simplify this sum. So having simplified this, we now have a square root in the numerator that we now have to deal with. But we know the trick, which is to multiply by the conjugate. And so I'm going to note that sort of really I have two pieces here. I have the 2 plus h and the minus the square root piece. So the thing I want to multiply by here is 2 plus h plus the square root of 4 plus h divided by, and then that same thing. When I do this, I'm going to get 2 plus h squared minus 4 plus h, all divided by, and now h times this horrible mess. Okay, this is going to require a bit more surgery, so I need to multiply this out. The 4 and the minus 4 cancel. I have an h squared, and then I have a plus 3h. That's what's left there in the numerator. It's easy to lose faith because there's so much mess going on here. But you shouldn't lose sight of what it is we're trying to do. Namely, what we're trying to do is cancel this h. And I'm actually almost there. Namely, if I write one more line here, I can factor out an h from the numerator. There, now I can cancel my h's. Having done that, we are now in the right position to do our final step. So our third step here is going to be to take the limit. So now I want to say k prime of 4 is, and so now it is going to be the limit as h goes to 0 of h plus 3 divided by, and then this whole thing. And what is this limit going to be? Well, it's going to be 3 divided by, and then this whole thing's going to work out to be 4 times, this whole thing's also going to work out to be 4, and so this is going to work out to be 3/16. And so that will be our answer. All right, that's all for 3.1. Next time, we're going to start talking about 3.2, where we're going to be talking about what you're going to do with all of these derivatives we've been calculating. So, admittedly, in this section, we've calculated an awful lot of these derivatives without really saying why. In the next section, I promise we'll start to get at that question of why. But that's all for now. I'll see you next time.